All right, good morning. This is our last lesson for Unit 3 with Trig. I hope that you've done well with the previous lessons, and if not, that you're going to tutoring because you do have a CDA next week, next Wednesday and Thursday on Unit 3. Everything that you've learned since I've been out. So please make sure you go back and review the videos. You will get a study guide next week, Monday and Tuesday. And then you will test on Wednesday and Thursday. The makeup day will be Friday, and you have to have prior permission from Miss Hall to come in and make it up on Friday. Okay? Alright, so our trig problems, they're going to use these words, depression and elevation. Okay? And they're referring to an angle when they talk about this. So, an angle of depression is when you have your horizontal line that will be on top. Okay, and depression means that the line that is not horizontal is going down, like you see me trying to trace this one right here. Okay, so the angle ends up on the top because we're looking at it going down. Okay, so anytime you see the line going down with the flat surface at the top, then you know this is going to be an angle of depression. When you see the horizontal line at the bottom, like we do in this example down here, this is where my new horizontal line is, okay? Notice that the line that forms the angle to make this angle right here is a line that is going up, okay? So you have to look at it from the point of view of the angle. We don't pay attention to the horizontal line, but the line that forms that angle is going up, so that's why we call it an angle of elevation. So obviously, in order for it to go up, the angle has to be at the bottom because then our line will extend upward. Whereas when we have a depression, your angle starts out at the top and that line will be going down. Okay? So let's look at what the difference is when we look at it to find our angle of depression or angle of elevation. For an angle of depression, the horizontal line will be at the top. And the angle will also be at the top. Alright, for an angle of elevation, the horizontal line is normally referred to as the ground, but it will be at the bottom. And therefore the angle of elevation will also be at the bottom. Okay, I know it sounds backwards to say that it's an angle of elevation and it's at the bottom, but in order to elevate, you have to start low and then go high. So that's why the angle ends up at the bottom here. For an angle of depression, you have to start high and then go low. So your horizontal line will be up here, and that forms the angle that is going down. Down meaning depression, and when it's going up, that means elevation. So we're going to use this to simply identify angle 6, angle 7, angle 8, which is this angle. It just couldn't fit in there because the number was too big, and angle 9. Okay, so we have to look at where the horizontal line is, and for number 6, the horizontal line is at the top. Therefore, the line that forms the angle is going down, so this would be an angle of depression. Alright, for angle 7, the horizontal line is at the bottom. Therefore, the line that forms the angle to make angle 7 is going up. And that makes this an angle of elevation. Alright, would you go ahead and try to identify what angle 8 would be and what angle 9 would be? So find the horizontal line and then trace the other side of your angle and determine whether it's going up or down. You have to start at the angle. Alright, so angle 8 should be, my horizontal line is at the top. So this other ray that forms the angle for angle 8 is going down, because remember the angles here, we have to trace from the angle. And so the angle 8 would be an angle of depression. And angle 9, the horizontal line, is at the bottom. So if I trace from the angle, from the horizontal line up, we are going up. So that makes this an angle of elevation. Okay? That's important just in setting up your word problem so that you know where the angle is. For the rest of the problems, your figures are already set up, so you don't have to worry about that. It is the same way on your CDA. So here's our first application. Applications is when, you know, they like to tell these wonderful stories, but this time we're using all of our trig functions. So they say, number 2, over 2 miles horizontal. So here's our horizontal piece, and this should be 2 miles, not 200 miles. Okay, 2 miles horizontal. Horizontal means side to side. A road rises 300 feet. Okay, so this is how high the road is increasing. So obviously this is the road here. Alright, they're asking us, what is the angle of elevation to the nearest degree? So in order for it to be the angle of elevation, remember it's going to be closer to the bottom because this line is going up. So that's why it's important that you understand whether it's going to be, your angle is going to be at the top or whether it's going to be at the bottom. Alright, so we would be able to just take these numbers and just plug them in using our trig functions, only this unit is set up in feet and this one is set up in miles. So we have to convert how many feet would be in 2 miles. And that's why they gave you this little increment here. Okay, so 1 mile is equal to 5,280 feet. So if I want to figure out how many 2 miles are, what am I going to do? I should be multiplying 5,280 times 2. This is going to tell me how many feet are. I can rewrite this unit, instead of using miles, I can use feet. Okay, so I'm going to use my calculator when I do that. 5,280 times 2 gives me 10,560 feet. So now I'm going to draw a line through the 2 miles, because whenever you're doing a problem, your units have to be the same. My units here, the units of measure, are feet. So I needed both of these to be feet before we could set up. So now we're getting to the trig part, so we draw our little stick man. And remember, the stick man is always drawn where your angle is, okay? Wherever the angle is, that's where you draw your stick man. So my angle's down here, so I'm drawing my stick man here. So if I look across from this side would be opposite. And this side would be adjacent. Because remember, the diagonal piece is always your hypotenuse. Alright, so SOHCAHTOA is how I decide what to use here. And you're going to go through this several times on your CDA, where they're going to give you some numbers in your triangle and they may not give you all of your numbers. You have to figure out which one of your trig functions to use. So since I have opposite and adjacent, I'm going to use the tangent function. Okay, so I'm going to set this up using tangent. So I'm going to say tangent of theta. I'm using theta instead of x because we're solving for an angle. Alright, equals opposite, which is 300, over adjacent, which is 10,560. And remember, in our calculator, whenever we're solving for an angle, when they do not give you the angle, then you use the inverse function. So I'm going to use tangent inverse 300 divided by 10,560. And that's going to give me my answer. Okay? You only use the inverse when you're solving for an angle. Alright, so I have to hit second and then my tangent button. 300 divided by 10,560. And remember to put fractions in your calculator, you're using division. So I hit enter. And notice up here, because you always have to look at the question to figure out how you're going to round. They said we need to round to the nearest degree. That means they don't want any decimals. They want it to be a whole number. So if I round this to the nearest whole number, then I should have 2%. I forgot to tell you to check your calculator and make sure that your mode was in degree mode. So make sure, just to be sure, if you did not get 2 when you round it, then you need to hit this button. Your mode button is right next to your blue button. You need to go down to the third row and make sure that the word degree is highlighted. You should have a box around degree with the little shading. This means that your calculator is in degree mode, and then we hit second, which is your blue button, and mode to get back to a regular calculator screen. Okay, so if you didn't get 2 degrees, it was probably just because you didn't have your calculator in degree mode, and you have to remember to do that on your test day. Okay, alright, so that's number 2. Alright, number 3, a 75-foot building. So here's my building over here. It's 75 feet tall. It casts a shadow of 82 feet. Okay, so this is the shadow of the building. What is the angle that the sun hits the building? Round to the nearest degree. So of course the sun is high. So we're looking at an angle of elevation here. Alright, so we start high and we go down low because the sun would be up here. Okay, so this is what we're looking at. The angle that the sun hits the building. Alright, so looking at what we're solving for here, they asked me again for the angle. Okay, so we first need to draw our stick man over here next to the angle, because that's how we figure out what opposite and adjacent and all that stuff is. The stick man always goes next to the angle that they give you or that you're solving for. Alright, so if I look across from my stick man, this would be the side that's directly across from him. So this is opposite. Alright, adjacent would be the side that's right next to him that is not the diagonal side, because the diagonal side is the hypotenuse. So, SOHCAHTOA again. Alright, and we have to decide what we have. So there's a number next to this side that is opposite, so I have O. And there's a number next to this side that is adjacent, so I have O and A. And the only function that uses O and A together is the tangent function. So we're doing tangent again. So the tangent of theta, and I just changed x to theta because we're solving for an angle, equals the opposite side, which is 82, divided by the adjacent side, A over here, which is 75. And every time we're solving for an angle, we use the inverse function. So you have to do tangent inverse of 82 over 75. That is how we're going to get the measurement of our angle theta. So let's type that in our calculator. Second and tangent is how you get the inverse button. And then 82 divided by 75. And once again, they want us to round our answer to the nearest degree, which means we need whole numbers. So I would say theta is equal to 48 degrees. And this is my answer. All right. Number 4. A boat is sailing, and here's my little boat over here. This is my boat. All right, it's sailing and it spots a shipwreck. This is the shipwreck over here. So I try to make it a little bit bigger so that it would represent like a ship. So it spots a shipwreck 250 feet below the water. So obviously this is the water, okay? And the shipwreck is 250 feet below the water. A diver jumps from the boat. It's my little man. And he's going to swim, okay, 935 feet to reach the wreck. Here's the wreck down here. What is the angle of depression from the boat to the shipwreck? So now they're looking for the angle of depression. We know an angle of depression should start high and go low. So they are referring to this angle right here. So I already have my stick man there, so I'm going to leave him there. Now let's figure out what size we have this time. So right across from that angle, if I draw a straight line, that always gives me the opposite side. Now this time, the diagonal is one of the sides with the number next to it. So that means I'm using H. So I have O and H. Let's write out. So, toa. Alright, so which one only uses opposite and hypotenuse? That would be the sine function. So we're doing sine of theta. Remember, I just changed my x to theta whenever I'm solving for an angle so I don't confuse myself. Equals opposite. This is the side that's opposite, so 650 divided by hypotenuse, which in our example is 935 feet. Now we're solving for an angle, so we have to do the inverse. So we're going to do sine inverse of 650 divided by 935, equals theta. Alright, so this time we hit second and sine. 650 divided by 935 in my calculator, and once again they want me to round to the nearest degree, which means I need to have all whole numbers. So the angle of depression in this example would be 44 degrees. Alright, any questions? You can pause the video and ask Ms. Hall any questions if you have them. Okay, so we're ready to do our last example. Number 5, a construction worker leans his ladder against a building, making a 60-degree angle with the ground. So the angle has to be with the ground, which is at the bottom. I don't know what's going on with my recorder right now. I'm trying to clean it up. Alright, so the 60-degree angle has to be with the bottom. Okay, with the ground, and the ground is going to be the horizontal position, so that means we have an angle of elevation here. Okay, if his ladder is 20 feet long, so here's the ladder and its measurement is 20 feet. How far away is the base of the ladder from the building? So the base is the same thing as saying the bottom. Okay, how far away is the bottom of the angle? How far away is the bottom of the ladder from the building? So we go from the bottom of the ladder all the way measured to the building, and that is represented here by X. Now notice that this time we are not solving for an angle because they gave me the angle. Okay, so remember we have to solve these a little bit different. We do not use an inverse function because we are not solving for an angle. Okay, so we're still looking from the point of view of the angle. I know that the diagonal side is hypotenuse, and I always draw my angle to figure out what the opposite side would be, and by default that means this side has to be the adjacent side. So here, the sides that have a number or an unknown value, the side that they're asking me to solve for is x, and the other side was 20. So ka toa. Now we're looking for which trig function we're going to use that has an a and an h, and that would be the cosine. Okay, so I forgot to draw my little stick man, but he should have been drawn over here because the angle is here. You always draw your stick man wherever the angle is, whether you're solving for the angle or the angle's given. That's the side that you draw your stick man on. All right, so we know we're using cosine, so I'm gonna say cosine. I'm not gonna say cosine and theta here because they gave me the angle measurement. So I'll plug in 60 degrees, and that equals adjacent. The adjacent side is x divided by the hypotenuse, which is 20. So remember, when we solve this, the goal is to get x by itself because we're solving for the side. X gets to stay on this side. That means 20 has to leave because anything that's on the same side as your variable, you have to get rid of. So to get rid of 20, right now we are dividing by 20. So we're going to multiply both sides by 20. Remember, this is the same step every single time that you will use whenever you're using a trig function to solve for one of the sides. So we'll multiply by whatever is on the bottom. So 20 cancels, and this side gives me my answer. I just have to type this in my calculator just like this. So this side is what I'm going to type in my calculator. So 20. Then I hit just the cosine button. Notice we did not hit inverse. We didn't hit second first. We just hit cosine. And then 60. And close your parenthesis. And so we get x equals 10. So the units that we're using here are feet. So that means the ladder is 10 feet away from the base of the building. Alright, and that concludes part 1 of your lesson, your application lesson for today. We will start part 2 in a new video. Thank you.